Suppose one day we found this Commodore PET outside sitting by itself. We bring it indoors. What exactly do we have here? In these videos, we will examine the PET. Using an emulator you can run on just about any modern hardware, we'll find out what the PET can do for us today. Let's start by looking at the hardware. There's a case that opens and it even has a kickstand to hold it open. Pretty nifty. There's a big power transformer in the corner, but the main feature is this big green board that spreads out over most of the floor of the case. This one was made in 1979 and was sold by Newman Computer Exchange at 1250 North Main Street in Ann Arbor, Michigan. It has a few modifications. Let's go over the standard parts first, then talk about the changes. Around the outside edges of the board there are several gold-plated connectors for plugging in other things. We're going to plug in a cassette tape drive. That's pretty much it. There are many ways to connect a PET to the rest of the world, and by far the easiest to use is the emulator. That's what we'll be doing most of the time. The parallel user port was once connected to an acoustic-coupled modem, and it also talked to a Petunia sound card. There is an IEEE 488 bus for connecting the PET to printers, disk drives, and maybe lab equipment. There's an SD card reader that pretends to be a disk drive, which serves as a convenient path to get to the internet when it's time to operate the live hardware. Here's the other cassette tape port. This one connects to device number 1. Device number 0 is the keyboard, device number 2, the other tape drive, and device number 3 is the screen. To keep things as simple as possible, these are the only devices we'll be concerned with. There's a lot of hardware in here and a lot more going on, but we're in a hurry to get to the end of the video so the programming can begin. What are all these chips then? Up at the front of the board there's a 32K random access memory or RAM chip. That is the maximum RAM allowed by law on this model of computer. Originally it was sold as a 16K PET. It now has the most recent version of Microsoft BASIC and twice as much memory as the day it left the factory. The batch of chips next to the RAM is the video circuitry. On later Commodore computers, this circuitry would be squeezed down into a single chip or two. The dots that display when the PET draws a character are in the character generator ROM chip. ROM means read-only memory and works like RAM, except, you can't write to ROM. Whatever is in the ROM chip stays the same forever, even when the machine is turned off. This character generator ROM is not connected to the address bus on the PET computer, which means it can't be seen by the CPU chip. These are the shapes that you get to draw with. There are 2 alphabets, and each alphabet has a reverse. Future Commodore computers, like the VIC-20, will be able to see and change what the dot patterns are, but not the PET. Moving toward the back, we find 7 ROM sockets. 5 of them have a ROM chip in them. The first 2 sockets are for chips we might purchase or create ourselves. The next 3 are Microsoft BASIC, then the screen editor, and last, the kernel. These chips contain the programs that work the hardware and let the human being operate the computer from the keyboard and screen. There are 3 more important chips, collectively referred to as the I/O or input-output chips. There are 2 peripheral interface adapter or PIA chips, also called 6520 chips. The other one is a versatile interface adapter or VIA chip with the number 6522. They connect the processor to external devices. There is this special add-on board called a PETVET that I plugged into the machine here. It has switches on it that let me use different ROM images and a serial cable that lets me observe the PET remotely from another computer and some other cool tricks. But the main chip on this board is the actual original 6502 CPU that came with this PET. This is the chip I think about when I think about the computer. The central processing unit can put a 16-bit address on the address bus and read or write 8 bits of data on the data bus. That's about all it can do. Oh yeah, it runs at 1 million clock cycles per second. The I/O chips, the RAM chips, and the ROM chips all have an address somewhere, and the CPU will very rapidly read and write to those addresses. That's it. That's the whole story of how it works. Think of the memory as being like bookshelves. but each book is just an 8-bit binary number between 0 and 255 decimals. You can read it, you can write it, but you can't do too much with the values unless they are inside the CPU in a register. The 6502 has one 8-bit main register, A, and two 8-bit index registers, X and Y. There are also 7 flag bits, an 8-bit stack pointer, and a 16-bit program counter. There are just 56 bits of total register space inside the CPU chip. Let's close up the case and turn it on. That case. It is said to have been inspired by Stanley Kubrick's movie 2001: A Space Odyssey. There's that trapezoidal shape and the microgram of font on it taken from the movie. But what about the PET part? The PET rock was a marketing phenomenon where a guy figured out how to sell rocks in boxes. He'd made millions of dollars doing this. Since nobody had ever tried to sell computers to people for their homes before, maybe they thought people who were stupid enough to buy PET rocks would be smart enough to buy PET computers. I don't know. But I do know that it shows 1,000 characters on the screen and has 74 buttons on the keyboard, or 73 if you have the original PET. I don't know how any of those earlier PET owners got anything done without a shift lock key. Abend, abnormal termination of software, crash, lossage, derives from an error message on the IBM 360. Used jokingly by hackers, but seriously mainly by code grinders. Usually capitalized, but may appear as abend. Hackers will try to persuade you that abend is called abend, because it is what system operators do to the machine late on Friday when they want to call it a day, and hence is from the German Abend, or evening.